Okay, so here's where we left off, as I recall. We decided that sine was not a one-to-one function. So sine by itself does not have an inverse. So we decided we had to limit our domain. What did we decide? We need to make our domain for sine in order to make it one-to-one. We decided we needed to work between negative pi over 2 and positive pi over 2 to make sine one-to-one. And how about our range? What kind of y numbers do you get when you're dealing with a sine function? Range is between negative 1 and 1. So for arc sine, it'll be just the opposite. The domain, the numbers that I can plug into arc sine are numbers between negative 1 and 1. And the range, I'll get y values between minus pi over 2 and pi over 2. Then we played the same game with cosine x. We drew a graph of cosine. We saw that cosine was not one-to-one. So again, we decided we better limit our domain to make it one-to-one. And for cosine, what did we decide made sense?
0 to pi.
0 to pi. And our range was exactly the same. So when I'm dealing with arc cosine, I can plug in numbers between negative 1 and 1. And I'm going to get answers between 0 and pi. All right. How about tangent of x? Is tangent a one-to-one function?
Yes.
Yes. No. Maybe.
Yes, it is.
One of those three answers is correct.
I know what.
You're going with maybe. All right, maybe is correct, but I would say, can you be more specific? Remember our tangent function had these crazy asymptotes. Pi over 2, 3 pi over 2. So it did this in between the asymptotes, and then it did it again over here, and then it did it again over there, and it kept going forever and ever. So is it one-to-one? No, because if I draw a horizontal line, how many times is that horizontal line going to cross that tangent graph? An infinite number of times, so it's really not one-to-one. So, what domain should we pick for tangent? Negative pi over 2 to pi over 2. So it's almost the same as sine. The only difference is for tangent, can I have the equal to's on the pi over 2's? No, because that's where the bad things happen. All right, so the domain for tangent is almost the same as the domain for sine. The domain is going to go minus pi over 2 less than x less than pi over 2. We just don't get the equal to's. How about the range? What kind of y numbers am I getting on my tangent graph? I'm getting all real numbers. I'm getting negative infinity to positive infinity. Okay, so when I deal with arctangent, what kind of numbers can I plug into arctangent? All of them. I can plug in all real numbers. Very, very different from the sine and the cosine. Sine and the cosine, when I was dealing with their arc functions, I could only plug in numbers between negative 1 and 1. For arctangent, I can plug in any number in the whole wide world that I like. So Think of how many questions I can ask you standing at the door. Too many, right? All right, and then my range. What kind of y numbers will I get when I deal with arctangent? I'll get numbers between negative pi over 2 and pi over 2. Okay. So then I was asking you questions, like I was asking you, what's the arc sine of square root of 3 over 2? And you went to that chart that you memorized, and this is the same as asking sine of what gives you square root of 3 over 2? Pi over 6? Pi over 3? Well, pi over 4, pi over 2. I'll throw out all the answers. What the heck? One of them's right.
Pi over 3.
Pi over 3?
Yeah.
Oh, I hear with confidence that the answer is pi over 3. And that's correct. The arc sine of the square root of 3 over 2 is pi over 3. Arc sine of negative a half. Negative pi over 6. Absolutely correct. Very good. Pi over 6. Arc cosine of square root of 2 over 2. Pi over what?
4.
Pi over 4. Wonderful. Pi over 4. Arc cosine of negative a half. Positive pi over 6 is not the correct answer. Say that again. Negative pi over 3 is not the correct answer. When I'm dealing with arc cosine, can I ever get a negative answer? No, I cannot get a negative answer. So pi over 3, the pi over 3 part of your answer is correct, but you're in, right. Negative pi over 3 is in the wrong quadrant. Negative pi over 3 is in quadrant 4. Cosine is positive in quadrant number 4. So if I'm dealing with arc cosine and I give you a negative number right there, you have to give me an answer in quadrant 2. So again, you look at your chart, you look at the chart for 1/2, you see pi over 3, but then you need to move that angle pi over 3 into quadrant 2. So you're going to do for arc cosine, that's always the rule. If this is negative, your answer has to be in quadrant number 2. Arc sine and arc tangent are easier. If you have negatives, you just give me a negative answer. Works out nicely. This one has to be 2 pi over 3. All right, so for example, I might give you arc tangent of negative 1. So you look on your chart, tangent of what will give you a positive 1. Tangent of 0 is 0. Tangent of what gives you 1? Not pi over 2. Tangent of pi over 2 is undefined.
No, it's the middle. Yeah, 2. And it's negative, so it's negative pi over 4.
Negative pi over 4 is the correct answer. I'm not sure if his reasoning was all there, but negative pi over 4 is the correct answer. All right, so again, you look on your chart, you ignore the minus sign for a minute. It's pi over 4. Arc tangent of 1 is pi over 4. Since it's negative pi over 4. All right, and then we started doing other crazy stuff, like, what was I doing to you? I was doing things like arc cosine of the cosine of 5 pi over 6. And the first thing you had to decide is you had to look at this number right here, pi over 6, and determine if it was in the right zone, in the right domain, in other words, for arc cosine. Is 5 pi over 6 in the right zone? Yes, because when I'm dealing with arc cosine, I'm dealing with things between 0 and pi. So 5 pi over 6 is in quadrant 2. It's in the right zone. So when I'm in the right zone, what do arc cosine and cosine do to each other? They just kill each other, so that's 5 pi over 6.
Question.
Yes?
Okay. Is there a scenario where you can have arc cosine sine?
Oh, yeah. I'm glad you asked. How would I do that? Arc cosine, having trouble spelling here, of the sine of 5 pi over 6. We'll stick with 5 pi over 6. That's a nice thing. Absolutely you can do that. Absolutely you can mix and match. Now it's harder, of course, because there's no way those two things are just going to kill each other. No way that's going to happen. So here's what you do. This is the arc cosine of, what's the sine of 5 pi over 6? Where's 5 pi over 6? Quadrant 1, 2, 3, 4. 2. So sine is positive in quadrant number 2. Darn it, right? Darn it. All right. So I look on my chart. I look for pi over 6. What's the sine of pi over 6? Sine of pi over 6 is 1/2. And we're in quadrant 2, so it's going to be positive. So we're going to have arc cosine of 1/2. So now we look on our chart. Arc cosine of 1/2 is pi over 3. So absolutely you can mix and match your functions. It's just a little bit more work. Let's try another one. How about the arc tangent of the cosine of 3 pi over 4? Well, we don't have to worry about right quadrant, wrong quadrant anymore because we got an arc tangent and we got a cosine. They don't match. So there's no more such thing as correct quadrants anymore. So we just got to work it out. So this is going to be the arc tangent. Negative square root of 2 over 2. No. All right, first off, how did you get negative square root of 2 over 2? 3 pi over 4 is in the second quadrant. The reference is pi over 4, so it's square root of 2 over 2. Cosine in the second quadrant is negative. All right, so what's the arc tangent of negative square root of 2 over 2? Because the tangent of pi over 4 is 1, not square root of 2 over 2. No, the tangent of pi over 3, I believe, the tangent of pi over 3, I believe, is square root of 3, and the tangent of pi over 6 is square root of 3 over 3.
There is no square root of 2 over 3.
So it's a complicated answer. It's not that there isn't one, because when I'm dealing with arc tangent, I can plug in any number in the whole wide world that I want. What this is this is not one of our famous answers that we know. So what are we going to do? We're going to grab our calculator. And that happens sometimes. Sometimes the best you can do is use your calculator. And I'm never going to take your calculator away from you. All right, first thing I'm going to do is I hit the mode button and make sure I'm in radians. For some reason I'm in degrees. I don't know why I was. Switch it to radians. So I'm going to hit arc tangent. Where's the arc tangent button? It's right above tangent. It's right on the same button. So arc tangent of negative square root of 2 divided by 2. And I would write that answer down. equals negative 0.615 rounded to 3 decimal places. So to answer your question, can you always use your calculator? The answer is yes. However, if I were to do this problem, if I were to type in arc cosine of the sine of 5 pi over 6, the calculator is going to give me a decimal answer like so. And if you can give me an exact answer like pi over 3, I want the exact answer like pi over 3. If you give me this decimal here, I'm not going to give you full credit. I want pi over 3 when the answer is pi over 3. I cannot math frac it. Why not? Because I've got a pi in it. It's an irrational number. It's not a rational number. I mean, I can do it, math frac it, but it's an irrational number. It's not going to give me the answer. All right. So what you really need to do is memorize that pi over 3 happens to be that number, and so you memorize all the pi over numbers and as these decimals, and then you can use your calculator.
Or you find the decimal, just add pi over 3 from that.
You could try that too.